Hey everyone! It is my great pleasure having you here at this shared webinar between Manus and Ntention on the topic of the future of interaction. It is also a historic moment for us as a company, as this is the first time ever we invite you behind our curtains to explain what Ntention is all about. Here, we'll take you on a journey to show both the hardware and software enabling the interaction systems of tomorrow. Before we begin, I'd like to show you the ropes of the webinar. To begin with, I will share some exciting context and a few good stories, like how we met our partners and friends at Manus and began our partnership. Sophie Kramer, their business development manager for Europe, will then give a great presentation showcasing their latest hardware solutions. After this, you'll hear from our CTO and co-founder Håkon Furu Petersen, diving into our tech and visions for the future. Accompanying him will be our head of design, Kasper Riise, talking about his findings in gesture-based interaction design. They will discuss how we use the Manus gloves to enable our interaction systems. And they will talk about certain use cases that work well with a gesture-based control system. They will also talk about the process of designing gestures and gesture-based control methods and the possibilities of future multimodality. When we started out in 2016, the hardware required to facilitate our interaction systems did not yet exist, and we had to build our own. We did this for a while, before our partners, Manus, reached market and we could use off-the-shelf, high-quality sensor gloves. Creating new hardware combining electronics, fabrics, and sensors is no easy feat, and especially not establishing a production line. This opened a world of opportunity for us, as we could suddenly bundle our software with the necessary hardware at the price point that was realistic. We are so glad we became friends with Manus, and only days after the release of their Prime haptic gloves, our software engineer Håvard and I were on a plane down to meet their co-founder Stefan. Since we've become the only certified reseller of Manus hardware in the Nordics, and we see that we can deliver together with Manus cutting-edge forefront control and interaction systems. When man created machine, all computational power had to go into the machine's core functionality. Hence, we had to learn to operate our machines on their terms, binary terms, and the concept of buttons was created. Add complexity with more axes, and we have the joystick controller, which was first introduced by United States Naval Research Laboratory and patented in 1926. Almost 100 years later, we're stuck in the same paradigm of operating most machines, through joysticks and buttons. The touchscreen is no exception. It is, in short, just a large programmable button that works through two-dimensional actions. In our current day and age, there's a lot of excess computational power that can be used to be the process of interaction between man and machine. Here's where we come in. We build the system in between. And how did this all start? Ntention was founded by Magnus Arveng in 2016 with the idea of a drone flying glove. Together, we built a great vision, a new paradigm of control and interaction systems. Fast forward some amazing and exhausting years, we work with interaction systems in concept spacesuits, robotic asset manipulation, and AR and VR applications. We often get in reply that we're operating way too broad, but this is not the case. We work within one trajectory: multimodal interaction systems with intention capture. Our CTO will dive into the details of this term. In short, what we do is that we use sensor and voice data to control machines instead of sticks and buttons, allowing users to use their body in a more natural way. The goal is to build a more natural and intuitive human-machine interaction. Just as what we're building can be useful in a coffee machine, it is easy to say it has higher impact in space, defense, medical, and industrial applications. We've been so lucky to choose our projects from the top of the shelf, focusing especially on an astronaut smart system, a versatile solution covering interaction design aspects with displays, control systems, and robotic asset manipulation. We are looking to dive deeper into value-generating industrial applications in the near future. We use AR and VR as intended in the future, a practical tool to create, but also an enabler for multimodal interaction systems. Instead of spending loads on building machines, we simulate them virtually. This allows us to develop and iterate much, much faster, and it has other huge benefits, like reducing the load on the environment, cutting training time, enhance understanding, and optimize communication. Also, the byproduct of virtual systems is VR content, which is quite attractive these days too. To enable all our virtual interaction systems, both for interacting with virtual physical objects, menu interfaces, and virtual robotic assets, we use Manus hardware. So without further ado, I'd like to give the word over to Sophie and Manus.
Manus is well known for designing and developing high-end data gloves for VR and motion capture purposes. Today, I will be showing you our products as well as present some use cases. Throughout the webinar, you are welcome to ask any potential questions you might have, which will be answered in the end. What a data glove does is communicating your hand movements to a computer. This means that the computer will know what your hand is doing without the use of any buttons. The great thing about data gloves is that it allows you to use your hands instead of controllers, creating a much more realistic experience.
Nice.
We are proud to announce our next generation data glove. Please take a look at the Prime 2 series. Here you can see real-time hand data from our Prime 2. As you can see, finger spreading is supported as well as overstretching of the fingers. Some of our use cases are industrial prototyping, which you can see here. This is an example of our gloves being used in the robotics industry. Here you see a user experience done by Skoda at a big event. Our gloves were used to give the user a realistic experience of actually driving the car. However, this was done in virtual reality. This year we released Polygon. Polygon is a full body IK system which enables you to use your full body in VR. In combination with the gloves, this is the perfect user experience. Here you can see a user examining a prototype of a car. He is putting on his trackers to experience it in virtual reality. At first, you can only see floating hands. Polygon enables the user to be in full body. With the support of multiplayer, he can share his design with a colleague that joins him and discuss any potential changes that need to be made. I want to thank Ntention for giving me the opportunity to present our products here today. If you have any potential questions, feel free to ask them in the chat box and I'll be happy to answer them.
Thank you so much for a great presentation, Sophie, and thanks so much to Manus. Next up, we'll move over to our CTO Håkon and our head of design Casper, who will discuss our visions for the future of interaction systems.
Håkon Furpetersen. I'm the CTO and co-founder of Ntention.
Yeah, hi, I'm Casper Rice, and I'm the company's head of design.
All right, Casper. To start with, let's take it a bit back to the overall goal we have in Ntention, creating an intuitive and flexible multimodal interaction system with a feature that we have called intention capture. It's a bit of a mouthful, but we're going to take you through it gradually here. But could you explain what the background of the goal is? What are we really trying to solve here?
Yeah, so when people interact with the things around us, we usually have a really clear goal of what we want to do and what we want to accomplish. But usually there's something in the way that restricts us from letting us do exactly what we want to do. Say, for example, you want to do some editing with a video software. The goal is pretty clear, but the tool itself is so complex and unintuitive that it hinders you from doing what you actually want. The same goes for if you're lying in a sofa and you want to turn on the TV. You have to reach for the controller, so it hinders you from doing what you do. So what we ideally would do is actually just read our minds and let the technology do exactly what we think. But the technology is not really there, and that's where sensor gloves like the Manus glove comes in and makes this type of interaction possible.
So now we have sensor gloves that can register motions, and we can use this for users to naturally convey their intentions to any machine or application in use. What can you actually do with gloves or even full body tracking? What kind of motions are you able to do, and how does this affect the way you operate machines today?
Yeah, so first of all, having gloves makes it possible to track gestures. And one type of gesture could be raising your hand to increase the volume on a TV, or snap your fingers to turn on the light in a room. But also for more industrial purposes, you can use a thumb to control some cranes or some robots. But you can also have gestures where you kind of continuously control something over a longer period of time. We saw the drone example previously, where you actually use a gesture that reads your gesture movements and you continuously control this drone. Or it could also be a robotic arm.
Yeah. Capturing gesture commands through sensor data processing is the first step. But of course, much remains in making the system usable and understandable. For example, a regular controller like a TV remote has buttons on it with symbols and letters and names, but our hands do not. So how does the application or the machine in use convey to you, the user, what you're actually capable of doing with your hands here? Because there's no indicators of what you can actually do. You just have the full free range of motion that comes with your hands naturally.
Yeah. So to be able to understand what you can do, what you're supposed to do, and how you do it, you need some sort of visible feedback in the system that gives you this information. And this is where the AR and VR comes in. It gives you the layer of information that you need to be able to interact with these things. I mentioned, for example, interacting with the lighting in a room, which seems really smart and intuitive, but if I actually gave you a set of gloves and a sensor tracking system and told you, okay, turn on the lights in this room, you will try something that seems intuitive, but in reality, you will have no idea of what you actually were doing. So by adding some visual elements to this interaction with the VR and AR, it can actually tell you that you're doing something wrong. It can hint you into knowing what to do. And this is where this really makes a big difference. And the same cases go for things in our normal life, like doors. We use hinges as a visual sign to know which way we're going to open a door. The problem is, though, that AR and VR is not really implemented in our lives yet. So these examples with lying in the sofa, controlling a TV, turning on the lights, is not really realistic in this day and age. So it's more applied in more industrial purposes for now.
Yeah. So you're bringing up AR and VR technology here, which is very interesting. It is kind of an emerging technology. It's been growing for a couple of years now. It has seen more adoption in industry use cases because, of course, the equipment is sort of expensive, but at least people notice that you can use it to optimize your workflow or use it for design workshops and processes like that. However, as is a tendency for emerging technologies, there's usually a hardware focus to begin with, a very focus on creating a sufficient screen quality or spatial tracking level for the HMDs or the head-mounted displays for the VR technology. And as a result, the software development kind of falls a bit back in line. Of course, I'm not saying that in every single VR headset the software is bad. The software is very good, but the interaction design has kind of fallen a bit back in line, where you, of course, you have to prioritize the HMD or the hardware initially. But the problem here is that you create a threshold for use. You create a system or an interaction system that is developed from the bare minimum that is required of the hardware, and you kind of iterate on it. You end up with controllers that are not fully optimal. You end up that they're at least shaped for your hand, but the buttons and the functionality don't always make sense, right? What instead, rather than just putting on a VR headset, taking the controllers and being able to do what you want to do, you have to spend a few hours learning the system. And this is suboptimal. Of course, if you're bringing in someone new to a VR project, there's always this learning time that they need to go through. And we believe that really developing the software further, making it intuitive and user-friendly, is how you can take VR and AR technology from being an innovative niche to mass adoption, both in industry and the consumer market. So, kind of like how Apple revolutionized smartphones with their own user experience and the user interfaces, which came and really brought smartphones up and out in the world, despite the technology being there for multiple years before. We believe that making the user experience more intuitive and natural, you can reduce the issues hindering the equipment from being used to their full potential. Like, we see a lot of companies have invested massively in VR and AR equipment, but they don't really see use because there's either a threshold of using them and applying them to your workflow, or it's just kind of daunting for a lot of people. Like, it's intimidating to pick up these controllers that look like soup spoons, and you don't know they have buttons on them, but it's not very intuitive. So December 2019, we had a project with a Norwegian construction consulting company called Norconsult, in which they wanted to get more efficiency and productivity out of their VR equipment. So what we did was we implemented sensor gloves into VR and let them use their hands naturally in moving around and interacting with a virtual environment. And the goal was to make it easier for the engineers and users to draw value out of the AR VR equipment and to ease their workflow, especially in multiplayer cases where you want to, say, iterate on a layout of an area or something where you can interact with the model hands-on together. So here we have a clip showing a VR application that we made for Norconsult.
Yeah, this is a really interesting case that really shows a specific and a really clear and valuable case for using this type of technology. And in the case we just saw, you see a fully immersed VR demo. But there are also several specific use cases that you can actually combine the same technology in the physical and real world. One example could be robotics, which is a domain that really suffer from complex and intuitive control systems.
Yeah, the robotics domain is definitely interesting, especially for spatial control systems or similar where you have to control something moving around either in a 2D or a 3D plane. We've worked with several demos and control methods, both for flying drones, controlling robotic arms, and just creating different gesture control systems that fit different use cases. Here we have a short demo reel of a few use cases we've looked at previously and that we're continuously iterating on.
Yeah, so it's a lot of cool project we've seen there, and some of them are fully implemented system, like the drone case we just saw, and also some of them are more research based. We saw some clips of a car where you use the hand to control the car, and it was a really interesting case we did to try to test the concept of this visualization I was talking about, giving the user the feedback they need to understand interaction. So in that case, the user we tested on was just giving this new interaction system and told him, here's a glove, try to control the car. And we saw if the visualization actually helped, which it did. So it really proves that there is a need, and it does really help to use these visualizations to aid this type of interaction. And we also saw some VR demos controlling this cube with this sphere, where we took the test environments into a virtual environment, which gave us much more freedom to build it how we wanted, to test what we wanted. And that's especially, as a designer point of view, a really interesting case going forward as well, to be able to make this interaction system and these modular test environments in VR.
Yeah. One of the clips in the demo reel was the robotic arm. It's actually the one standing behind here. And we'd like to use that as a bit of a use case that we can look at to showcase how we can approach a gesture-based design process for an industrial application. So we have the beautiful robotic arm. It's multi-jointed. It has a grip claw that you can grip with, and it is made to test different control methods like different gestures or movements. The different joints can be controlled by finger motions right now, but let's take a step back and approach the design task with a more conceptual perspective. There are multiple use cases for a robotic arm like this. It could be used to solve certain tasks or move objects around. Could be used in a variety of industries. Where do we go from here?
Yeah, so the first thing you would do is to understand what the user really wants. And we can assume that the main goal is to control the head of the arm, meaning the claw. So you can say, okay, let's focus on that. That's what the user wants to interact with. So we could say, okay, we want to just move the head from a point in space from A to B, and then use some sort of gesture to enable that. And then it would be to find a gesture that was fitting to a reference that the user had. It could be a kind of a gesture that's showing an axis in space, which is a known reference to many when you operate with 3D space manipulation. And And then basically just using this gesture, controlling the arm, the head of the arm, and just ignoring how actually the arms and joints would move accordingly.
All right, so assuming you find a good gesture for controlling the grip claw then in a 3D space, you're now able to move the grip claw around like from point A to point B. But moving it around is not the only capability of the robotic arm itself. It also has the grip functionality, but it could also have been mounted on something else and moving around, and you'd have to control what it is mounted on. There are a lot of options there, but assuming that you have a robotic asset that has multiple functionalities, how would you go about that when you need to be able to use multiple features either parallelly or in between each other?
Yeah, so this is where the power of gestures really come into play. If we follow the example from previous where we said, okay, you're controlling the head with this gesture, you can position it where you want by kind of following the metaphor of dragging it around in space. And then when we get to a certain place, you can change the gesture into something that's mapped to kind of a claw, and you can actually grip and use the grip functionality. So then you actually combine things which is really simple, just with your hand gestures that anyone can do, and comparing that with doing the same with a standard controller is actually a really complex and hard thing to do.
Right, so you made an animation clip here showcasing a multitude of features where we switch in between gestures. Let's take a look at it. All right, yeah, that's pretty cool, Casper. Well done. So, assuming you can switch between multiple functions of a single robotic asset, there's still the case of having multiple of them, like multiple robotic arms, multiple drones, for example. That is another thing we have worked with. Often some with different features, like say a robotic arm and a drone. How would you go about changing what asset you're currently controlling, especially when you have a continuous gesture, like for example when you're flying a drone, moving between the gestures may actually interfere with the robotic asset that you're currently controlling, right?
Yeah, so until now we only talked about gesture-based interaction and focused on the hand gestures. But this is where we kind of bring the interaction system to another level, where we introduce what we call the multimodal interaction system. So in the case you mentioned, by controlling something and you might want to swap the gestures, it might be some sort of overlap. You can actually use voice inputs that you give the command to the system, changing different maybe control system of the claw or the position. And a great example of this scenario is when you want to control multiple robotic assets, but also control some AR or visual overlay, for example, space exploration.
Yeah, we showed it a bit earlier, but together with the NASA Hot and Mars project and Collins Aerospace, we are working on an astronaut smart system. Now, this system will allow a future astronaut to interface naturally and intuitively with robotic assets surrounding him or her. And it will also allow them to perform a wide variety of tasks, for example, with drones in interplanetary field operations. The whole point is to reduce the cognitive load of the operations themselves and let the user focus fully on the task at hand.
Yeah, and the astronaut smart system is a great example that also shows the benefit of having this interaction system where the body is physically restrained. For the astronauts spending the time in space, their suits are pressurized, making every movement really hard to manage. Therefore, if we design this gesture interaction with the voice commands, you can actually track gesture, really fine-tune the gestures, and still be able to do quite a lot of advanced interaction system that wouldn't be possible giving them as the traditional drone controller or even any controller to do these advanced interactions.
Mm-hmm. It sounds very advanced. To conclude what Ntention is all about, we aim to create intuitive interaction systems. So you build on multimodality and you give any user the capability to interact in a way that is natural to them. For example, for me, I may want to use gestures more, or you may want to use your voice or even your eyes to communicate what your intent is, right? And by giving a lot of opportunities of input methods to a user and combining this with the contextual information from the application in use, like for example the state of a robotic arm, the state of a drone, or the state of a VR application, you can combine this into the term intention capture. By combining all of your body movements, maybe your body language, your attitude, your gestures, your eyes, maybe even long-term your neural impulses, with the knowledge of what the capabilities of the system currently is. Like, for example, like a drone, if it's just standing on the floor, there's only really one thing you want to do. It's to take off, right? Mm-hmm. And combining all of this, you can try to get what the intention of the user is with the system and allow them to just do a flick of the wrist or give them a thumbs up or anything that is natural to them to really control the drone here. So we're building a system that allows the user to directly convey what they want to do with the machine. And finally, the required hardware to make this software happen, or make this software able to exist really, has finally caught up to a level where it is feasible to dive into the interaction theory and the design of creating such a system. So to conclude it up again, it's really about multimodal interaction systems with intention capture, where you give a user wide variety of input methods and you allow them to do whatever is natural to them. And let's take it back to Moina here, as we have concluded our little deep dive into interaction design here, especially gesture-based interaction design. Thank you for hearing us here.
Yeah, thank you.